And let's make a next step and let's get mobile, so to say. I'm really happy that George Hunter is with us today from Carnot, from the UK. And he's introducing a startup that is dealing with the most efficient net zero powertrain in the world. And we are really curious to learn more about this. George, the stage is yours.
Good morning, everybody. Thank you for joining us. So my name is George, and I'm from Carnot over in the UK. And we are tackling the $1 trillion gigaton problem of decarbonising industry, transport and power. And more specifically, we're focusing on heavy-duty power and long-range transport applications. Now these sectors currently account for about 13% of global emissions, or about 6.6 gigatons of emissions annually. And yet despite this, there currently exists no production-ready technologies which can help these sectors to decarbonise. So what are their options? Well, firstly, of course, we've got the conventional combustion engine, which has been a very, very loyal workhorse for the last 100 years or so. We like the engine because it's a very high power density, easy to maintain, very durable, great range, and yet it's got the big three problems. It uses fossil fuels, it generates a lot of emissions, and it's inherently inefficient. Second up, of course, we've got the battery. Now, electrification is a great technology when you're looking to decarbonise short range, low load applications, but when you start scaling to the sorts of applications we're looking at, they become too big, too heavy, too expensive, and they are impractical. And finally, of course, you've got the fuel cell. Again, a brilliant technology when it comes to sort of medium load applications, but they scale laterally, and they do not have that power density you need when you're talking about these heavy duty markets. Well, so what is the solution? Whereas our conjecture is what you really need to decarbonise these markets is a highly efficient, zero emission engine. And that is exactly what we're trying to develop here at Carnot. So what we are, the world's most efficient engine is sort of the core of our technology. And how we're doing this? Well, for a start, we've achieved 70% thermal efficient engine. And we've achieved this using a combination of advanced technical ceramics, quite an innovative engine architecture, completely eliminating the need for a cooling system. Which has allowed us to get to these 70% efficiency. A conventional engine, for example, will have to suck out about 30% of the energy you generate from your fuel. Immediately, you have to get it out of the engine in the form of cooling to stop the metallic components completely failing. And this is where our technical ceramics are so powerful. But more than that, not only have we got this 70% efficiency, we've also made this completely fuel agnostic. So whilst ultimately we want to be using hydrogen, ammonia, combined fuels, in the transition period we can use biofuels, we can use e-fuels and a variety of other options, which provides a really flexible route to get to net zero for our clients. So to give you a little snapshot of some of the projects, some of the traction we're working on, so we've got two of our big partners at the moment, Oz Minerals and Carisbrook Shipping. Oz Minerals is a big mining syndicate in Australia, but I thought Carisbrook was particularly interesting because what we are developing at the moment with Carisbrook is a hydrogen ammonia auxiliary power unit to go on a marine application to be used in shipping. The reason we use hydrogen ammonia is because hydrogen obviously still cost is quite high, and we can offset the cost of the hydrogen using the ammonia. But also from the shipping industry, they use ammonia regularly for refrigeration and other applications, so there's a regulatory framework there we can work with, and we're working with a lot of the classification societies to make this happen. So a few takeaways from this, which were quite exciting. So firstly, we were actually cheaper than diesel. So with these efficiency gains, we can actually save money. So there's no green premiums to get to deliver these net zero solutions. In terms of the emission saving as well, each engine saves 1,740 tonnes of CO2 equivalent a year, which is quite a substantial saving. And this sort of leads towards our main goal as a company. We aim to be a gigaton saving technology. And then, of course, on the NOx issue. Now, NOx obviously is the stuff that makes acid rain and bad respiratory problems. And it's always been an issue with hydrogen combustion. Hydrogen likes to burn very, very hot, which is brilliant in some regards, but we've actually worked out this. If you get your fuel-air mix right, your NOx emissions drop off a cliff. And so on this latest one, we are 0.04 grams per kilowatt, which I appreciate means almost nothing, but to give you an idea, the most stringent standards in the world, and this is the California standards, and this is less than 10% of what they say you needed, but we will be at 0 NOx very soon. So it's the first of its kind technology, and we believe that this is delivering net zero power right now in an affordable manner. So to give you an idea of kind of where we're going, we aim to be sort of in low volume production by 2026. But our key next phase is our pilot trials. So we've already got 2 field trials agreed. We want to do up to 5. So if there is anybody out there with a particularly challenging emission reduction problem, we'd love to hear from you. We're working on everything from HGV hydrogen programs through off-grid, biofuel projects in the Philippines, with all sorts in between. So the bigger the problem, the better for us. And yes, we're also raising at the moment. We're raising about 2 million sterling, predominantly to deliver these the phase 2 engine for these field trials, but also maximise on a few quite exciting new opportunities we've got recently. But through a startup program, we're in the infancy of establishing a partnership with Mitsubishi, which for us is pretty big, and we've also won another UK government grant, about 350,000, to deliver auxiliary engine. So we need some match funding for that as well. Anyway, I've been given my marching orders. Oh, yes, well, some of our cars. We're also a University of Oxford spin out, which is always nice. Anyway, I've been given my red card, so I will vacate stage, and thank you very much, everybody.